Last section. Woohoo, we can celebrate. This is section 8.2. 8.2, we're going to talk about just one little aspect of section 8.2, just so that we have the ability to be very flexible in the things we solve. In section 8.2, we're going to talk about what's called the quadratic formula. Just to refresh your memories, if an equation has a degree of 2, an exponent of 2, and it's like this is called a quadratic equation. So we did this way back in chapter 5 when we were talking about factoring. Ax squared plus bx plus c is equal to 0. And this right here, when you have a degree 2, when you have a power of 2, this is called a quadratic equation. And we have just a little bit of experience solving a quadratic equation. In fact, we are just going to do one quick review problem from what we did in chapter 5. We are going to solve this equation right here. We're going to do this one together just for kicks. We're going to solve this. X squared minus 6x minus 55 equals 0. Okay. Well, let's go for it. The only way we have at this point in our lives to solve a quadratic formula is to do it by factoring. So what we did is we took this trinomial. We said, okay, x squared has to be x times x. This negative in front of the 55, this negative in front of the 55 tells me what about my signs of my factors? Negative and a positive, or a positive and a negative. The order does not matter. That is indeed true. And then I need the two factors of 55 that are going to be 6 apart. And they are going to be, sure, 11 and 5. And I made the 11 the negative one because they have to add up to negative 6. When we're able to factor, then we say, okay, I've got two things I don't know multiplied together. They're equal to 0. So that means either the x minus 11 equals 0 or the x plus 5 is equal to 0. In this case right here, when I add 11, my x is 11. In this case right here, when I subtract 5, I get negative 5. Okay. And those are our solutions. So what we want, though, is in the case that if this was like a 54 instead of 55, and I couldn't factor it, or if I have something where the numbers are inconvenient and I just don't see what the factors are, is there a way to solve any quadratic equation? And the answer is, of course, yes. It'd be a bad question to ask if the answer was no. So what you could do alternatively, and this works for any quadratic equation, whether it factors or not, you can use what's called the quadratic formula. Now, time does not allow me to derive the quadratic formula for you. That would be fun and kicks in itself. But this, you do need to know this. Okay, this will be handy for you. Here's the quadratic formula. Quadratic formula says if this is my quadratic equation right here, then the solutions, the x values, are equal to. Has anyone seen the quadratic formula before? Anybody remember this? It's one of those things right on the tip of your tongue, right? You know you've seen it, but that's okay if you don't remember it. I don't assume that you remember or have seen it, but it goes like this. What you do is you take negative b. So whatever this value of b is right here, you change the sign of it. There are more often than not, there are going to be two answers. There's going to be an answer where you add, and there's going to be an answer where you subtract. That's what this symbol right here means. This is a plus or minus symbol. It means that you're going to add the next value, and then you're going to go back and do it again. You're going to subtract the next value. So instead of writing the quadratic formula twice, you just write it once with a plus or minus here. Then you have a square root. This is the hardest part of the quadratic formula. So if you're going to memorize it, which I think you should, start by memorizing what's under the square root. It's called b squared minus 4 times a times c. All of that is the numerator. Then you draw a big fraction bar underneath the whole thing. And the denominator is a lot simpler. The denominator is just 2 times a. So this relationship here will solve any quadratic formula for you, or excuse me, solve any quadratic equation. So we have about 18 minutes left in our class time. So we are just going to plug and chug as many times as we can into our new good friend, the quadratic formula. So here is an example. I'm going to work this. Let me work this example with you, and then I've got one or two that you'll do. So here's our first one. Let's do this. Let's solve 4x squared minus 11x minus 3 equals 0. I don't know if this factors or not. I don't care if this factors or not. We are going to use the quadratic formula in order to solve this. Notice, just like factoring, though, you have to set it equal to 0. This doesn't work if there's anything else over there. So it has to always be equal to 0. It has to be in this format right here. Once you have it in this format, though, tell me, what is the value of a of this quadratic equation? I'm sorry? Not the x squared. All you need is the 4. A is just the number. Okay, so it's simpler than you thought. Then what's the value of b of this quadratic equation? Negative 11. The negative is important. Glad you included that. And then what's the value of c of this quadratic equation? Negative 3. Once you identify the numbers, it's just, and once you remember the quadratic formula, which I can't help you with that, you've got to remember that. Get a 3x5 card, write it down while you're having Thanksgiving dinner, leave it on your lap, memorize it. No one will even know you're doing math. It's just plug and chug now, okay, at this point. So here we go. Starts off with negative b, the opposite of b. So you just told me a minute ago that b is negative 11. So what is negative b going to be? Positive 11, great. Plus or minus, we'll talk about that in a minute. The square root of b squared. What's negative 11 squared? What do you get when you throw that in your calculator? Positive 121. Yes, when you square this negative number, you get positive 121. Minus 4 times a, which is 4, times c, which is negative 3. All over 2 times a, so 2 times 4, or if you want to write down 8, that's fine. Anytime you're doing the arithmetic, again, what I would recommend, I always do the same thing every time so that I know that I'm doing the right thing. What I would do if I were you is I would start by multiplying these 3 numbers. That would be the next thing I do. Just do one thing at a time, and we're going to multiply those numbers. So I got 11 plus or minus 121, and now let's multiply. What's negative 3 times 4? What do I get when I multiply those two things together? Negative 3 times 4 is negative 12. And then that negative 12 times this negative 4. You write it here so they can't. Negative 12 times negative 4 is going to be positive 48. We're not adding, we're multiplying. Negative 3 times 4 is negative 12. Negative 12 times negative 4 is positive 48. So the first thing I would do if I were you is I'd multiply those 3 numbers together. It's always a good first step. 2 times 4, that's 8. I'm going to take this, I'm going to go over there so that there's room and the people on the video and you all, everybody can see it adequately. Next thing I'm going to do is I'm going to add or subtract whatever I'm supposed to do, those numbers that are under the square root. So underneath the square root, I have 11 plus or minus the square root of 121 plus 48 is 169. I would always take a shot at this. If you got a number there that you don't recognize, like 169, put 169 in your calculator and hit the square root button just to see if it works out. What is it? 13. Now, if this doesn't work out, then you might have to simplify it, or it might not simplify at all. Okay, so in some of the problems that we do in the next few minutes, you'll see a little of each. But this one works out. So 11 plus or minus 13 over 8. And now here I go. I'm going to get my 2 answers. I picked this problem first because I wanted to show you what the plus and minus means when the root works out. So first, what I'm going to do is I'm going to add. So I'm going to cover up the subtraction sign. What's 11 plus 13? Okay, so that's 24 over 8. That's going to be the first answer. And then the second answer, what's 11 minus 13? Negative 2 over 8. That's the second answer. And I'm just going to reduce both of those and we'll be done. 24 over 8 reduces to 3. There's my answer. Negative 2 over 8. Well, that's a fraction. 2 goes into both of those, so it's going to be negative 1 over 4. There are my 2 answers. 3 and negative 1 over 4. And then I'll write that as a solution set. There it is. That's the quadratic formula. So we have time for at least 2 of these problems. So here's one for you. I would like you to solve this. 4x squared minus 8x plus 1 equals 0. Just to make sure we're all using the right values. What's the value of A that you're plugging in? 4. What's the value of B that you're plugging in? What's the value of C? Great, great. Just wanted to double check with you. So, I mean, the most important step is this next one, plugging in the numbers in the right place. And then it's just an arithmetic problem. So my solutions, my x's are going to be negative b. So if b is negative 8, what is negative b? I'm not, this is just negative b. You're a step ahead of me. You're over here. So negative b. What's the opposite of the value of b? It is 8 plus or minus. Now, underneath the square root, I'm going to square b squared. So negative 8 times negative 8, when I square that is 64, minus 4 times a, which is 4, and c, which is 1, all over 2a, so that's 2 times 4. So like I said, the way I would proceed is I would start, I'd multiply these three numbers together. So first, these ones right here, 1 times 4 is 4. 4 times negative 4 is negative 16. 2 times 4 is 8. I'm going to take the problem over there where I have some clean board. And so over here, I've got 8 plus or minus. Then underneath the radical, 64 minus 16 is, what's that, 48? Yeah. No, that's a great question. Common mistake. Whatever b is, whatever its value is, you're squaring. Okay, so b is negative 8. So what we have is negative 8. We're squaring it. So that's negative 8 times itself, negative 8. And that's why this will always be a positive number when you square it. Okay, so great question. Glad you asked it. So now 8 plus or minus 48, if you go down the perfect square factor list, it has a perfect square factor. It is 16 times 3. This is what we were practicing earlier in the chapter. This is the product rule of radicals. The square root of 16 is 4. Then I have the square root of 3. And then the very last step is to reduce. And I noticed that all of my terms can be reduced by a factor of 4. I'm going to make a little note here. We're going to reduce by 4. So 4 goes into 8 2 times. 4 goes into 4 and leaves 1. So just 1 square root of 3. And then 4 goes into 8 2 times. And there's your two solutions. The top is not like terms, so you can't take that any farther, and you are done with the problem. All right, here's our last problem for the day and the last problem of new material for the semester. So give yourself a pat on the back. You've made it. You've just got one more test now. You've got a final exam. So you're almost there. Remember, today and tomorrow, the Polk State is open. My math lab will work even while you're on break, if that's what your time allows. But please, if you don't want to do anything over the holiday, Wednesday through Sunday, get as much done as you can in these 2 days. That way we have that test when we get back on Monday. Okay, so I don't want that to get you unawares. All right, so here's the last problem for the day. Use the quadratic formula. X squared plus 4x plus 13 equals 0. Once again, I just want to double check we're plugging in the right values. What's the value of A of this problem? 1. What's the value of B? 4. The value of C? Okay, great. Keep going. Got this. just for time's sake, so I'm not shot on time. Just going to plug and chug. Again, it's super important that you remember what the quadratic formula is. That's the big challenge. You can see identifying the A, the B, and the C is not super big deal. The A is always in front of the x squared. The B is always in front of the x. The C is always the number added on. So my negative B, this time B is 4. So negative B is going to be negative 4 plus or minus the square root of B squared. 4 times 4 is 16. Minus 4 times the value of A, which is 1. The value of C is 13. And all of that is over 2 times A, so 2 times 1. Okay, so now I have all of my numbers in the proper location. That is the second big challenge. And now it's an arithmetic problem. So negative 4 plus or minus 13 times 1, multiplying these. 13 times 1 is 13. 13 times negative 4 is negative 52. 2 times 1 is 2. Underneath the radical, 16 minus 52, when you pop that into your calculator, what's 16 minus 52? Negative 36, that's important. That was basically the reason we did that last section is so that we could solve any quadratic equation. Okay, because that negative under the radical, that's my imaginary unit. So I have negative 4. If you don't need to write this step down, I get it, but if you do, that's fine. So we have negative 1 times 36. Square root of negative 1, what is that? I, that's my definition. Square root of 36, 6. And last but not least, here are my 2 answers. I can now divide. I can distribute this 2. 2 goes into negative 4, negative 2, plus or minus. 2 goes into 6, 3i. There's my 2 solutions to that quadratic equation. Complex numbers can be solutions to quadratic equations. That's part of their significance to us in the short term and why we talked about them.